The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Introduce you. So today we are delighted and are privileged to have Dick Hill as our guest lecturer. Dick will be talking about the famous Molyneux problem that Alex and I have referred to in our lectures. This is one of the deep historical problems that touches upon the nativism versus empiricism debate, besides many other aspects of cognition. So, without further ado, Dick.
Well, let us return to the 17th century, where John Locke announced his use of Molyneux's question in his own work, inserting it into his book, as you know. And here is the statement of it. Do you all know this, by the way? We don't have to repeat this. But I would like to ask you, if you'll raise your hand, if you would answer yes to this question. Would you mind raising your hand? On first seeing this question raised, did you answer yes or no? Would you raise your hand if you answered yes? Very good. And no? Who would say no? Okay, the class is evenly divided. So that's good. That's a fight. Well, Locke inserted this, and people have been troubled with it ever after, you might say. Why? You can see that here's a number of people who've worked on this problem. In case you're interested, you can follow it up with a vast number of people who've worked on it, philosophers, other kinds of scientists, show people, and so on, in the 18th and 19th century. And then in the 20th, we tend to get people who want to actually examine the evidence for this. And they've done so. And for us, neuroscientists, I say us, I mean me, and Pawan and a few others. The question is the development of cross-modal recognition. When is this available at birth, or is it developed over time in experience? And if so, what is that experience? That's our question. And the philosophical aspects of it for psychologists are sort of lost, although not gone completely. How should we answer this question? Well, first of all, the proposal was, and has been for a long time, to find congenitally blind people due to treatable causes. Treatable causes are those that are essentially occlusive pathologies, meaning that the avenue to getting light onto the retina, focused, has been disturbed by one thing or another. And generally that's either cataracts, corneal opacities, or a high refractive error. And about 20 cases have been reported over the centuries. And the question is, can you do these subjects perform these cross-modal, will they recognize visibly the objects that they knew by touch? And that's the question. But it's not so easily answered, and people have tried to answer it, have not been completely successful. You've got to get subjects who are capable of vision and yet have not enjoyed vision because of these occlusive conditions. Now, why is it there are so few cases? One of the reasons is that in modern times, when such cases are found early in life, in infancy, surgery is applied and the occlusion is removed very early. That's before we can get verbal answers from our subjects, which we want to get. We want to know what they're observing, and we want to control their behavior so as to test. And if they've been, if they've had therapy and they can see, we can ask those questions. We can test them. But we can't do it in the highly developed nations because of the health services. But there are places, India is one of them, as you can see on this map, where a large number of children are born blind or suffer from blindness for one reason or another due to lack of access to medical facilities. And they grow up blind, at least to a certain age, because there's a very difficult time in India for a blind child. So, here you see some examples. The upper case, of course, is a cataract, two cataracts, and the lower case are corneal opacities. Both of them would obscure clear vision. Our access to these patients in India is a result of the work of guess who, your own instructor here, Dr. Sinha, who had the foresight to set up this Project Prakash, which you may have heard of, which has two purposes. One is a philanthropic one to try to bring medical services to these curably blind in India who have very little access to medical services. And second, to provide subjects for our experiments and for understanding better what the blindness means, as well as the post-operative development. And that's allowed us to go to India and to study these cases. As you can see, we're studying very hard here in India. And that's of course, studying visual acuity using these Landolt-C figures. The gap in that circle gets smaller and smaller as we try to get down to the smallest possible opening, which is a measure of acuity. Now, the second thing that's very important in testing these patients is that they have sufficient acuity, sufficient vision after operations to be able to test them for visual discrimination, as well as tactual discrimination. So, here is the essential parts of testing in actual behavior, the Molyneux question, of asking that question. First of all, as I mentioned, pre-op vision has to allow light sense. In other words, the patient before surgery must be able to distinguish light from darkness, but not to have form vision as such. Second, after surgery, the patient has to have sufficient resolution so as to recognize forms. Now, we know they're probably not going to have 20/20 vision, but it should be sufficient to recognize the figures we're going to use for testing. We managed to select a few such subjects in India and to test them in further work. Now, the test paradigm you can see here is shown here. What we do is we do a two-alternative forced choice in this manner. On the left, you see the example that is shown. Let's say take the touch. T is for touch or haptic discrimination. Subject is given an object to palpate, to feel, and then is shown that same object again, plus a distractor object. And the question is, will that patient post-op recognize the object he or she felt before surgery or before the initial part of the test? Feel this and then feel two other objects, one of which is the same. That's just to test touch, but we know they're good at touch. The next question is to test vision in the same manner. Take a look at an object here, post-op, and then present that same object and a distractor a short time after, and see if that original object is recognized as the previous one. And then finally, having shown that the patient is capable of touch discrimination as well as visual discrimination, we can do the cross-modal test. Feel this object and then look at that object and a distractor object and see if the felt object is now recognized as the seen representative of that same object. Okay, so that's how we proceed with that discrimination. And here are some sample stimulus pairs. You can see the subject or the patient will examine one of the pair, and then after that, both of them will be presented, and the subject has to pick out the one he or she saw a moment before. I hope that's clear. And we had actually found 3 subjects that we reported on. And here is the first of them, Yazvir, bilateral congenital cataracts, pre-op light sense, satisfying that requirement. Surgery, January 12th of 2007. And here is the way the procedure is carried out. This is my experimental assistant. You can see this is the visual discrimination. The object was presented first, and then 2 more, and the subject has to pick out the one he saw in the first place. Okay. Here is another experiment. The 2 objects you see here, and the patient is allowed to feel one of them. You see under the cover here. And then he's looking at both of them. See if he can recognize the one he just felt. That's the cross-modal procedure. And you can, just to prove that we're in India, you can hear Hindi spoken. We were there. Okay, now here are the results from Yazvir. Visual match to sample. In other words, how is the vision? 100% success. In other words, the patient now is quite capable of doing the visual discrimination. Tactile match to sample, 100%. But visual match to tactile sample was not significant. You recognize that we've got a 50-50 chance of picking the right one since there are only two alternatives, and 55% is not a significant result. Two more subjects, Bablu and Priyanka, 17 and 16 years old, one with congenital cataracts, the other with corneal opacities, and follow-up experiments, the same kind, very soon after surgery. These were carried out. Vision is okay, touch good, but again, the cross-modal vision, touch to vision, not significant. Same with this Priyanka subject. Okay, so based on these results, the answer to Molyneux's query seems to be no. They don't seem to be capable of the cross-modal recognition of what they feel. They can't transfer to vision. However, we notice one thing very important. These patients were retested a few days later. And guess what happened? They showed themselves capable, at least two of them, of the cross-modal discrimination several days later. Now, how could that happen? There was something was acquired in the interim between immediate post-op and perhaps 4, 5, 6, 7 days later when two of the others were tested. So there's some very rapid kind of learning going on of a type that raises questions. What kind of a mechanism can produce such rapid learning? This is something else. We won't dwell on that. Okay, now we want to get to the next group.
Dick also then show you some very interesting other pictures. But
Yeah.
if you leave a couple of minutes at the end of the talk.
You have more pictures? Okay. All right. Now here's the proposal for how this learning can occur. And we'll get to it. Now, the transfer from touch to vision if you look at your hand and you move it, so we simultaneously both see and feel the same object. Well, what is involved in doing that, as this young woman is doing in this picture? What could be going on? Well, it suggests that somewhere in the brain, if you like, in the nervous system, there are representations of aspects of touch and aspects of vision which are mapped together as is attempted portrayal in this roster here that you can see in the middle between vision and touch. In other words, pieces of vision, pieces of touch, if you will, are mapped together. I won't try to refine that further at this point. Are mapped together so that when an object is felt, or the hand itself is felt, there's an immediate transfer to vision of what is involved in that object. So that the normal visible, seeing person can transfer back and forth from what they see to what they feel, and vice versa. You all can do that. And presumably there's that internal mapping of the system. However, if you consider our blind patients, initially before surgery, they have this haptic roster of positions and so forth, but they don't have, obviously, by definition, they don't have the they don't have the visible paired aspects of what they're feeling. Now, when they acquire vision after surgery, they will acquire a set of seen positions in space, but if we look at that middle roster, they are not connected by these red lines as we demand for the operation of cross-modality. That connection is presumably absent initially. And what is needed is the final roster, the formation of these red arrow connections. And the question we have is, how does that happen? It just takes a few days after surgery and acquisition of vision. Well, what I'm proposing is that what's happening is very much is a process we call capture, and it's illustrated by the rubber hand experiment, and as well as prism adaptation. How many of you managed to do the rubber hand experiment? Have you heard about it? Okay. How many did it? How many observed it? Okay. All right. What happens in the rubber hand experiment? Both hands, both the rubber hand and the real hand are palpated. Let me see. Here's the illustration of it. Are simultaneously palpated. Can you see that on the left? Rubber hand, real hand, experimenter palpates both simultaneously, while the observer, or the subject in this case, is seeing the rubber hand being palpated, while his real left hand is not seen, but is felt, palpated by the experimenter. And what happens is that very soon, in many cases, not all, the rubber hand begins to feel like the real hand. The rubber hand captures, so to speak, the real hand. And that's called an out-of-body experience, or an experience of body ownership, except it's not part of the body, it's a rubber hand. It appears, the real hand appears in that, feels to be in that position. And you can, on the right side, you see a actual photograph of what's happening. Now, once, if you ask about visual haptic transfer, you would not expect transfer if, I want to go back, you would not expect a naive subject to recognize that his felt hand is the same as the seen hand if they are separated in space, as by a prism or by this procedure of the rubber hand. You wouldn't expect them to identify the visible view of the hand with the felt hand. But after a bit of practice, Let me find this place. After a bit of practice, after capture occurs, these two hands are felt superimposed, and presumably the correct mapping has been reestablished after this capture procedure has occurred. And that presumably allows of transfer. And that would look something like this. Initially, the connection between haptic and visual is not congruent. There may be connections, but they are not effective for transfer since they are not coupled together. They've been separated by the actions of a prism. However, the capture procedure produces this congruent relationship, and after that, presumably, transfer is possible. So, I don't want to get to that yet. I also wanted to point out that the rubber hand procedure is analogous to prism adaptation. I think you can all see that. Instead of a rubber hand, the subject in the prism experiment is looking at the displaced image of his own hand instead of the rubber hand. And the displaced image is the seen image, and the felt image is shifted, is taken over by the seen image, as in capture. Now, if that is the process that operates, it will presumably allow us to start from uncorrelated sensations of touch and of vision, and to form these couplings of touch and vision, which allow us to do this cross-modal transfer. And that's at least the theory that I'm proposing. Now, if that works, it should also account, or could in principle, account for what happens in infancy. Because if we believe that this correlation develops in time and isn't present at birth, then we have what you see on the left. We have touch and we have vision in the infant, but it's uncorrelated. They are uncorrelated until the infant has experienced this relationship between touch and vision and develops these connections between the two, the internal representation of these connections shown here on the right. And after that, presumably, they will show evidence of cross-modal capability. Now, I mentioned in that paper on cross-modal transfer that a group of Italian scientists have claimed that infants of only a few days old are capable of making a cross-modal discrimination. But the strange thing is that, first of all, it took some time, a couple of days at least, after birth. And secondly, the transfer to vision was only shown by one hand, touching and feeling an object and then recognizing it visually, from only one hand to the sight of something, of an object. The other hand didn't work. And that suggests, I'm suggesting, that because this process of capture is so fast, it could be that it is acquired by the infant in the first two days of life. For one thing, if you've observed newborn infants, they spend a lot of time in what's called the asymmetrical tonic neck reflex, posing like this, more or less, and obviously looking at their hands, since that's where their hands are. So it could be, and I would claim, that that's how the infant acquires this connection between touch and vision. So if one looks at the picture in general about if I'm trying to explain the relationship between touch and vision as a developmental process, I'm in the empiricist camp in terms of neuroscience. Whereas the nativist camp keep pushing the origin of these discriminations back as early as they can find it in behavioral studies. So that's about where the field is. There's a battle as to who can get to the earliest possible time. And eventually, it seems to me, people, if they go on this way, are going to look at the fetal capabilities at mathematics, for example. Maybe there'll be ways of testing that. That's the way it's going. And we empiricists who believe it's acquired in some way will have to find some techniques for studying acquisition. So I want to leave it there, but ask you for your questions. I'd be happy to entertain those.
Thank you very much.
Thank you. Question? Yes.
I think what's striking is how many people put up their hands at the outset to say they thought that the newly sighted person would be able to. And I think that has an explanation which may connect with what's somehow missing. It seems to me to be missing in the story you give.
Yes. What would that be?
That's the sense that I think people have the square has a point. There's this angle, it's pointed. Now, if you feel it, you feel a point. And there is or now take this position, nice, smooth. Looks smooth, feels smooth. Looks sharp, feels sharp. And I think this looks as if it describes what happens, as it were, externally to the object. Whereas what one feels a desire for is something that goes into the internal to features of the
Well, you would assume then that sharp point in touch would be recognized as sharp point in vision.
Well, I wasn't one of the people who put up I put up my hand saying, no, I can't do this. And that's what is a problem here is, it's not just whether you'll get the answer right, but whether he's got a good reason for getting the answer right.
Good reason to do that.
Not clear that he does. I mean, so that I don't find those results, experimental results, surprising at all. I was just thinking about there seems to be something missing, because what seems to be involved when people learn the linkages is not just that the square shape is accompanied by the square look and the round shape is accompanied, but that something internal to it is that these features go together. And
Yeah.
that.
Well, I didn't want to try to get into what these letters are. I mean, that's complicated. Yeah, I think.
This is kind of like the
Yeah.
experimental finding of Takiti and Molyneux, or if you say here are two objects, one which is kind of bulbous and curvy, and another that's more like a star, and you say the names of these two objects are Takiti and
Voluma, yeah.
Columba. Which name goes with what? Most people pick Takiti as the name of the star, and Volumba as the name of the bulbous thing. So there's some inherent mapping between how the name sounds and what the appearance of the object is. So
There's some internal mapping, and it's, I guess, the story of that, what goes on in constructing that mapping. It feels to be missing in this.
You want more content for those. Yeah. Yeah.
So in other words,
I can believe that.
Contingently, we notice that whenever you're actually looking at something square as this.
I'll work on it. Yeah. Other questions? Yes.
It seems to me that also contained in your question, though, is the fact that it seems what you were testing was object identity. Is this the same object? Versus whether certain properties like spikiness or roundness transfer. So has there been any effort looking into that? Like if someone knows the concept smooth because they felt smooth things, can you show them something smooth and say, is this smooth? Like, does it have this property that you learn linguistically?
Yeah, I'm not sure what the question is. Yeah.
The question is whether you think it'd be any different to simply identifying, is this the same object versus does it have these properties? So maybe figuring out if it's the same is a more difficult question.
Yeah. Well, I'm looking for identity here as the first step. I agree. There are more subtle possibilities. Yeah. I agree. Yeah.
Were there any tests done on control experiments, and what were their results? Because it wouldn't necessarily be the same, because regular people don't spend their time necessarily feeling things as much as blind people do. They may not have the same touch ability as blind people. So I would actually be curious to know what the same experiment performed that a regular person might have.
So the question is, do control subjects perform well on these tasks, or is this just an inherently difficult task, being able to transfer from one to
You mean non-patients? Yeah, they do very well on these tests. Yeah,
clear a ceiling,
yeah,
100%?
yeah. Yeah,
Question of that.
yeah.
So it seems our body has a pretty good mechanical sense of where it is at any given moment, like where our arm is, where our leg is. Even people who lose their legs can kind of still feel it.
Yeah.
So in the second test you ran, when you're implying that the visual sight of tactile touching is overriding that body's mechanical kind of positioning of itself.
I don't follow you.
The proprioceptive sense that you have in the rubber hand of you, some aspect of your proprioceptive sense is telling you that your hand is still
It's still there? No, I don't think so. You will feel your hand is at the rubber hand if this works, and you won't feel the other hand. It's gone.
So my question is that then overriding that mechanical system that your body uses to determine the position of various parts? Is that what you look looked into? Or?
No
Yes,
problem.
this capture essentially. Yeah, so the answer to that is that, as Dick mentioned, there is the phenomenon of capture, which implicitly implies that you are ignoring the true sense position of the hand, and instead imputing that the rubber hand is your correct hand.
Yep.
So you override the proprioceptive sense.
Yeah. When it works, it's quite surprising that you'd lose the sense that you have that hand, and that you have the rubber hand instead. Now, it's interesting that this capture process, of course, is built into the system. It's innate, as far as we know. So we end up anyway being nativists in that sense, that process is intrinsic and built in development somehow.
So, Dick, I have a question.
Yeah.
So in your theory, the synchronicity of sensations is paramount, and that is what is causing the development of the
Right.
connection between
Right.
the two senses. But by extension, would desynchronized input lead to a breakage of the maps?
That's a good question. I would expect so. Prolonged desynchronization would destroy these maps, yes. I would think so, yeah. Well, if you think about it, at one point there were very popular deprivation studies where people were put into isolation systems and deprived of sense of light and activity for long periods. And they did lose control to some extent. Began to hallucinate, among other things, and so forth. Those experiments have lost their popularity for some reason or other. But there was a period when brainwashing was very popular, so-called brainwashing. And it was alleged that our enemies in certain countries were brainwashing prisoners by using those techniques of destroying these connections, I would call them, yeah. Yes.
There's an interesting neural correlate of this mapping. LTP and LTD, long-term potentiation and long-term depression. If you take two neurons and you try to see what kinds of activities imposed on these two neurons would lead to a strengthening of the connection between them. So akin to the red arrows that Dick mentioned. Synchronized activity leads to the development of synaptic strength, but desynchronized activity leads to a depression or a weakening of the synapses. So at the single neuron level, there is a conceivable mechanism that can implement the idea that Dick proposed.
Yes.
So, this is a really simple question. I was wondering why you didn't use spheres and cubes, and instead you used more complicated objects.
Convenience, I think. Really.
I mean, one of the reasons, so I was somebody who raised my hand at the beginning and said I thought that you should be able to tell them apart. And I think this relates to Judy's question, but one of the reasons why it seems like you might be able to tell them apart is because, this is sketchy, but something like when you hold the cube, you can distinguish between different parts of the cube. So there's different sides of the cube or something like that. But when you hold the sphere, there aren't really different parts of the sphere that you can distinguish. It feels like just one object.
Yeah.
That's something very simple and very different between those two objects that you might be able to, visually, as we talked about earlier with Pavan, even when somebody just regains their sight, when they look at a cube, they see three objects. When they look at a sphere, they just see one object, something like that. So that seems like you might be able to, with some simple reasoning from the fact that you felt different parts of one thing, identify that same thing, but because you see a number of different objects before you. But it seems to me like that sort of simple using would be lost if you use more complicated objects the way that you did in your experiments.
Yes, but you're assuming that those simple differences are the same in both modalities. That is, you've got a corner here and a flat surface here, both in touch and vision. But that's an assumption that those two are the same. I agree that abstractly they're the same, but are they the same in perception, if you will?
I mean, you don't need to be able to re-identify, a corner as something that you feel and then something also that you see. You can just, I see your point, but it seems like if you're just using a sphere and a cube, there's something very, very basic, which is just that this thing has parts and the other thing doesn't. And you look at both of them. One thing that you're looking at has parts and the other thing doesn't. And you do need to make a connection between feeling different parts in the sense that you can feel different parts in the sense that you can see different parts. But that seems more likely that you'd be able to re-identify them across modalities if you're using such simple shapes.
Well, actually, the people who did this early infant study claimed that there was a so-called amodal recognition, and on the basis of exactly what you're saying, that there's something that transcends each individual sense. Corner, flat, amodal, not specific to any sense. That's the claim. Is there such a thing? But they claimed that this amodality was specific to one hand because they only found it with one hand. That seems to me absurd, to find some abstract thing which is contingent on one hand. So, but the battle goes on between, if you like, empiricists and nativists in this sphere of early development. I don't know how that relates to the more philosophical significance, but that seems to me the way it is in neuroscience. Yeah.
So some people who give a yes answer to Molyneux's question could still accept your data. These people who want to distinguish between being able to have visual sensations and seeing. I have in mind Gareth Evans. So he would say, well, someone who just acquires the capacity to use his or her eyes gets visual sensations. But in order to see properly, these sensations have to be integrated in some way, in a more general representation of the world, so that you have to be able to act on the basis of your visual sensations and say, I guess, in general, these sensations have to be hooked up to one's general dispositions. And so I'm wondering, when your subjects failed the recognition experiments, exactly what were they able to do? Were they able to use visual information to, say, walk around without bumping into walls? Were they able to grab objects, at least in a rough way? Or were they in the stage in which they were kind of building up these abilities?
Well, the acid test was, were they able to do this visual discrimination test and the touch test? Yes, they were. Before doing the transfer test, we made sure they could do the vision alone with the same objects and the touch alone with the same objects. Only then did we ask, could they go from touch to vision? So they had the capabilities of seeing, if you will. I mean, does that get at your question? Now, you're asking more general questions. Are they able to locomote and get around and move?
Was visual information integrated in their more general abilities? That was...
Yeah. Yes, they were, I think. Yeah. I mean, simple answer to that. Yeah. Okay. Now, I think we better terminate because there's a threat of execution if we don't get out of here. So,
thank you.
Thank you. Yeah, I gotta work this out though. Touch alone with the same objects. Only then did we ask, could they go from touch to vision? So they had the capabilities of seeing, if you will. I mean, does that get at your question? Now you're asking more general questions. Are they able to locomote and get around and move?
Was visual information integrated in their more general abilities? That was.
Yeah. Yes, they were. I think. Yeah. I mean, simple answer to that. Yeah.
Okay.
Now I think we better terminate because there's a threat of execution if we don't get out of here. So,
Thank you.
thank you.